Hi, everyone. I think we'll get started. Thanks for coming out today. I know it's late in the week. You guys are tired, but appreciate the interest in Azure Automation and PowerShell DSC. My name is Joe Levy. I'm a program manager on Azure Automation. I also work on service management automation and orchestrator. With me today is Mark Gray.
How you doing, guys? Mark Gray. I'm a program manager on the desired state configuration team, and we've been working very closely with the Azure Automation folks to bring this solution to you. And I'm actually really excited to show you guys what we have today and get your feedback and stuff. So,
a lot of really cool stuff today. Real excited to talk to you about it. All around heterogeneous hybrid configuration management using the Azure Automation service. So really what we're going to talk today about is what is Azure Automation, cover that a little bit, why you'd use it, what it's great for, talk about what PowerShell desired state configuration is, and then talk about the kind of merging of the two, the new PowerShell desired state configuration features that are a part of Azure Automation that make configuration management really easy for not just Azure VMs, but on-premise VMs, VMs in OpenStack, VMs in AWS, physical hosts, anything you want to configure in a desired way, in a, not desired, declarative way. That's the word I was looking for. Thank you. So the problem at a very high level, which I'm sure a lot of you have familiarity with, is in an enterprise scale environment, it is not easy to keep the thousands of servers running my services configured correctly. It's incredibly complicated and error prone, right? And the reason for that, if you look into the details, is because there's many servers to configure. There's various roles for those servers where everything within a role needs to be configured exactly the same, but different roles need to be configured differently. You need to be able to scale instantly and have new servers, new infrastructure, VMs that come up, conform to that configuration and match the role, the rest of its kind of brothers and sisters in the role. Different employees and applications on the VMs or physical hosts can go and make changes to the VMs to take it out of your kind of desired state for the infrastructure to be in, and then things get messed up and you have to know about that and go set it back to the right state. And then as applications demands change, you need to be able to change what your desired configuration for one or more roles is and easily roll that out to all of the different VMs or physical hosts involved in your infrastructure and your services without losing availability of the applications or services built on top of the VMs. And different people are responsible for different pieces of the configuration. You might have a team responsible for the firewall versus someone responsible for the application stack. It's not everyone gets access to everything when it comes to configuring your infrastructure. So with that, we'll kind of start with Azure Automation. So how many people in the room are using Azure Automation already? Cool. And if you're not using it but familiar with it? Great, great. So most of the people cover those two roles. So for those of you who don't know, just a brief overview, Azure Automation is a highly available, scalable, reliable workflow execution engine that lets you automate all the manual, long-running, error-prone, and frequently repeated tasks that you take to keep your cloud and your on-premise data centers up and running. And it really allows you to take those menial but frequently repeated tasks that have a lot of steps, and some of those steps may have errors, and then you end up in a bad state if you do something wrong. Take all those tasks that are always repeated, always the same way, put them in the hands of our automation engine, and open up your own time to do something that adds more business value than kind of just running these repetitive tasks over and over to keep your cloud and data center up and running. Azure Automation is part of the new Operations Management Suite, which Satya talked about a bit in the keynote. And basically what it's all about is, until this week, we kind of targeted Azure Automation and Op Insights as well at Azure workloads. But Operations Management Suite is all about taking these management as a service things, automation, analytics, and recovery, and targeting them at your infrastructure wherever it may be, Azure, AWS, on-premise, OpenStack, VMware. Wherever it is, we can manage it. We can do it without you having to go and set up a lot of infrastructure and manage updates to the management components themselves, offering it as a service. So the big kind of parts of Azure Automation is runbook authoring. So we have a PowerShell workflow-based engine. You can bring in your existing PowerShell scripts and PowerShell workflows and use them in our engine. We also have a browser-based editor to allow you to, from any device, from anywhere, go and work on your PowerShell runbooks. The highly available engine has strong tenant isolation. It uses PowerShell workflows so you can suspend and resume if you have a long-running task that may run into issues. And then again, because it's PowerShell, it has the ability to integrate into any system. There's tons of PowerShell modules, PowerShell content out there today. So integration into Azure, Linux, AWS, your on-premise environment, anything. It can be done very easily with Azure Automation. Just some examples of things people do with Azure Automation. All kinds of different operational tasks that you want to automate so that you save yourself some time. It could be purging stale logs from SQL when you see that SQL is approaching its maximum amount of data it can store. It could be patching VMs in Azure or on premises without having downtime to the services on top of them. So some orchestrating patching processes. It could be automatically remediating alerts. So maybe a service is stopped or something has crashed, automatically going and restarting that based on monitoring a system that is able to alert you to things going down, such as Op Insights, such as Operations Manager, or doing a staged deployment of a service where you get the bits from source control, deploy them into staging, run your test suite. If those pass, then orchestrate the process in production of updating the production infrastructure. Again, it's built on PowerShell workflow, and basically we act as kind of a management service for PowerShell. So today you can use PowerShell all you want ad hoc and do things, but we kind of make it more democratized. We're a management layer for PowerShell. So you can track all the jobs in our system, what happened, who started it, what input did it take, what output did it create, when did it run, where did it run in Azure or on premises. You can use our secure backend to store encrypted information if you don't want to hard code secrets into your scripts, or you don't want multiple scripts to reference the same piece of information, and then when that piece of information changes, have to go to all these scripts and update it. You can now just update it in one place in our kind of asset store behind the scenes. Variety of real solutions built. You can look over these when you have the deck. Just want to make sure we have time for everything in here. And so now I'm going to do a little demo of Azure Automation, specifically in the context of configuration, because we're talking all about, I have some desired state that I need my VMs to match with. How can I make sure that my infrastructure matches that state and continues to match that state at a later time? So I have a set of runbooks in here. This is the new Azure Automation interface. And basically, what I've set up is I have a runbook called set IT rules. And what it does is you give it a set of VMs to go. Oh, of course, I've been logged out. So let's log back in. But what it'll do is it'll actually run against one or more VMs on premises or in Azure, the same exact runbook, and then make sure it aligns with your IT rules, whatever they may be, your desired configuration. In this case, what I'm saying my organization's policies is that the Operations Insight agent needs to be installed on all of my infrastructure so that all of that logging information comes up into OI. I can constantly have monitoring, real-time monitoring on everything going on, whether it's in Azure, AWS, on premises. That's my rule. Everything needs to have Operational Insights agent installed and pass information up. So I'll drive down into the details of this runbook in a second, but first let me just start it, both targeting a VM in Azure and targeting a VM on-premise. So you can see I'm clicked into my Set IT Rules runbook. I'm going to start this up, and let's put in the info for the Azure VM first. And then I'm saying use a credential asset that's stored in my backend, so I'm not actually exposing that credential in plain text anywhere. Since this is an Azure VM, I'm going to run it in Azure. And that's going to start up. And then I'm actually going to, instead of looking at that job, I'm also going to spin up a parallel job that happens to target on-premise by using the hybrid runbook worker feature that we just introduced at Ignite. So I'll target to use the hybrid runbook worker in my Contoso on-premise domain. This happens to be the VM I want to check. And then the credential to access this set of on-premise VMs is stored in my Contoso credential, which is stored in my asset store. So I'll start this up as well. So now both these jobs are running, and what the job is doing is going and checking, hey, are these VMs aligned with my policy? Do they have the Operation Insights agent installed? If they don't, go and install it and notify the administrator via email that something was not following the IT rules so that he can maybe go chat with whoever had turned that off, or just make sure there's no pattern of this continues happening on the same VMs over and over, right? So these jobs will start up. If I click into the runbook just to show you it a bit. So essentially what it's doing is I'm taking that information and I am remoting into the VM. I'm checking if the WMI object for the Microsoft monitoring agent is there. If it's not there, then I'm actually running a script to install that agent. And then I'm also sending an email, which is, the email part's a little long because it's coming up with the email, attaching an image to it, which I'll talk about in a little bit, and also sending it. So all this is that. But you could put this in another runbook so that you can call that email functionality from any runbook just by referencing this runbook inline within that runbook. So just to show you, if I go over to my VM in Azure, you can see that the MMA agent, the Operational Insights agent, isn't there right now. So it's not really following the rules. Whereas my WAP VM, sorry, my on-premise VM, you can see does have the Op Insights agent on there. So it is following what I've set are my desired configuration rules for my IT policy. So if we go back to our jobs, you can see both of these jobs that I just started completed. Let's check which is which. If I click into it, click into my output, I can see, okay, this was the one run against my Azure VM. You can see it's saying that VM was not compliant. I have auto-corrected that, and I've sent an email to the administrator to let him know something was not following configuration rules I defined. So now if I go to the VM and actually refresh this, you can see the Opt Insights agent is there. Not only did it check, hey, are you following the IT rules, but it went and fixed them, and it went and notified someone, so you have some reporting on what's actually in compliance with my rules, what's actually not following the rules. And the other one, I can check it real quick, but it'll just say, hey, that VM was fine because it had the agent installed. So I'll click into that job, click into output, and you can see the on-premise VM that Azure Automation ran against was following the rules, so it didn't take any action. If I go to my email now, you can see I have this new email. Joe123cloudapp.net was not following your IT configuration rules, so it tells me about that. You could put any information you want in an email, right? It's just one of the different services you can integrate into from Azure Automation is email. And you can see in this case, the administrator may be sad that he keeps getting these emails about people not following his rules. So in this case, I've sent him, I actually have a bug in my script. It's saying it's sending pictures of cute puppies. You can see there's a bug. This is actually not a cute puppy. It is a cute kitten. So, and just like that, what I've shown is basically how you can use Azure Automation to write PowerShell that actually enforces configuration. Make sure things are following the rules you've set, and actually, if they're not, goes and sets those rules in place and lets you know about it. And the way I did that happened to be, it's much better than manual, right? If I'm doing this across thousands of servers, I don't want to manually go check this. I want to set up a runbook on a schedule that reaches out to all these servers in Azure, AWS on premises, and checks whether they're configured correctly to match the rules of my organization. But to do this, I still had to write, as you saw, imperative scripting code to say, remote out to those VMs, go check those VMs for this stuff. If it's not there, go send an email. That's how I did reporting. If it's not there, go and fix it. Here's the actual script to run to fix it. I'm saying the process to go to actually not just check whether the configuration is there, but set the configuration and report on it. Not to mention I have to open ports on all of those VMs, not necessarily to the public internet, but still have to open ports so that I can remote into those VMs and actually check against them. So what if there was a better way than having to write scripts and open ports to specify the desired configuration for your VMs? So that's the next thing we're going to talk about. And with that, I'll turn it over to Mark.
All right, thanks, Joe. So I'm going to talk to you guys about desired state configuration just by itself right now. How many of you guys are familiar with, or how many of you guys use desired state configuration? Okay, that's a good number. And I would assume most of you are aware of what it is. All right, so I'm just going to give you a relatively quick overview of DSC and then give you a demo as well. So if you guys have seen presentations on DSC, you'll see some of this stuff that we've done before. But desired state configuration as a whole, as Joe kind of alluded to, is declarative syntax inside of PowerShell. So it ships with PowerShell. It's a feature of PowerShell. I'll talk to where you can get it a little later on at the end of this section. But it is a feature of PowerShell, and it gives you the ability to declaratively say, this is a state I want my system to be in. I'm not going to tell you how to do it. I just want you to be this way. I want you to look this way. So it simplifies configuration. PowerShell made a big step forward in scripting and simplifying things and making things predictable and stuff like that. And DSC kind of goes one step further into simplifying code even more, and you'll see it as I show the examples. But all of that logic that Joe had in his script, where you have if, then, for loops, and all that kind of stuff, you don't need that with DSC. It's all declarative property values that you can look at 6 months down the road and say, I know what this thing's doing, and to change it to what I want to do now, all I have to do is do this and change this thing. You don't have to dig through 150 lines of code. So it does a lot of simplification there. We give you the ability also, because DSC is part of Windows and it's an agent in Windows, we give you the ability to say, this is a state I want my system to be in, and I want it to stay that way. So I want DSC to run on a regular basis, and if the system falls out of the state that I put it in, put it back. Or if you don't want to be that dramatic, you can say, just tell me that it's out of the state, and I will do something about it. I'll either force it to be put back or what have you. But we give you that ability without having to go run a configuration on a regular basis. We give you the ability to actually keep your system in the desired state. And we also give the ability to have flexible deployments. And what I mean by that is, with PowerShell, like Joe mentioned, you have to reach out and touch a machine and run a configuration. With desired state configuration, you have the ability to do that if you want. If it works for your environment, great, go do that. But we also give you the ability to pull. So I have 1,000 systems out there, and I want to configure all of them. And all I have to do is configure those systems to go look at a central location. And then I can manage all my changes up on that central location, and the servers will just pull their configuration when I make those changes and get updated that way. So you don't have to have ports open on the machine. You just have to have access out to your pull server. And lastly, it enables continuous deployment. So we've done a lot of things in DSC to really enable this scenario where I have a web app that I'm going to deploy, and I have configuration that I need to do along with that. And I have, as part of my process, I deploy to my development environment, then my test environment, and then my production environment. And in a scenario like that, a lot of times you have little things that change in the configuration. So when I deploy to my development environment, I want IIS and SQL installed in one box. But when I deploy to my test environment, I want one SQL server and 3 IIS servers. So I want those configurations to be separate. And then lastly, like production, you may have 10 SQL servers and 100 IIS servers. So you can change stuff like that without changing the structure of your configuration. So some of the things about DSC and how we simplify things, other than a declarative script, we do all of the things that are in a traditional script, like dependency resolution, your intent, your logging, your reboot resilience, technology-specific stuff kind of gets separated out in DSC. So in DSC, you have your intent, which is that declarative script that I mentioned. It's a very simple script that is just, this is how I want the system to be. There's no error handling in there and all that kind of stuff. It's all in a separate part of the system that's all already taken care of. Then there's the technology-specific stuff. So that's all the stuff about, like, to configure SQL, you have to do all of this stuff, and it's very complex and all that kind of stuff. That's taken out and a lot of times handled by different people. So the person who really knows SQL can create a resource, as we call it, to configure SQL. And I, as a SharePoint deployment person, can use that thing without understanding the ins and outs of how SQL needs to be configured. I can just say, I want a server named this, I want a database named this, and I want these tables named this, and I can use that thing that the database guy did. So that's the resources. Then there's the DSC engine, which does all the error handling and all that kind of stuff that you don't have to deal with in the script. So it abstracts that away and makes it simplified that way. Where am I pointing? So the configuration drift, I'll go through this very quickly because I think you guys get it. With a PowerShell script, a traditional script, you push it out to a target node it configures the thing, and it's in the desired state that you want it to be in. You're all happy. Now you have a bunch of other machines that you want to configure. You push that same script out to all of those machines, and they get configured the way that they want to be, or you need them to be configured. And then a couple of them fall out of compliance, and you have no idea that they fell out of compliance because you're not monitoring it on a regular basis. So the way to fix that is to have something running in the background on the machine, and then to fix it, you have to go push that script back out to those machines and fix them that way. So it's a very manual process, even though you're doing some automation. With desired state configuration, you run that declarative script, which I will show you in a minute. You push that out to the target nodes, or the output of that to target nodes. That lives on the target node, so it's a document that sits on the target node and is consumed by the DSC engine on those nodes. So those get consumed. The system is in the state you want it to be in. You're all happy, and then a couple of those machines fall out of the desired state. Then the DSC engine runs in the background and says, hey, this thing is out of the desired state, and it can put it back very easily. So you don't have to worry about it, or you can be notified that it's out of the state, and you can figure out what you want to do from there. And the last bit is the components and phases. So this is kind of, get this thing to go. You have the authoring phase, and that's the declarative script that I talked about. And then there are third-party tools and things like that that can make use of it. What happens with DSC is you have authoring, and then that generates a MOF document, which is an intermediate language file. You can do that through PowerShell. You can do it through third-party tools. It doesn't matter. If you get that MOF document, the intermediate language file, you can send that to a target node, and DSC will take that and use it. So what that allows is for third parties to build UIs and things like that on top of DSC. So they don't even need to use PowerShell under the hood necessarily, although it probably would be easier. They could technically just generate that MOF document, send it off to the DSC engine. DSC engine would consume it, be super happy, and just move on like that. That is the staging area, is the MOF. So you run the script, you generate the MOF, and in a push scenario, which I'll get to in a minute, that's on the local machine. And then there's the make it so phase, and that's the smart bits with the resources and the DSC engine and stuff like that. That's what receives that MOF and figures out what to do with it. And that's one of the key things there, is it is idempotent. So you can run that configuration over and over and over again, and it's going to end up in the same state that it was the first time you ran it. So the way that that works is we have a test and a set. So the engine basically says, I'm going to test this thing and see if it's in the state. If it is, I'm going to skip the set altogether. So it has that smart logic built in to do that. So the push model is essentially, you run your configuration or use your UI, you generate the MOF file, you push it off to the DSC engine. The DSC engine receives that configuration and enacts it. What we've added in some of the newer releases is previously you had to have all of the resources and stuff like that that are needed for a configuration on the box already, or you needed to have some process to install them. With the new versions of DSC and WMF5, we give you the ability to push a configuration to a target node, and if it doesn't have the resources it needs, it can go up to a central location and pull those resources down. So you don't have to do like you did in earlier versions, where the only way to get those resources from a central location is to pull the configuration down from a central location. So that's in the pull scenario. You run the script, generate the MOF, put the MOF up on the target node. There's a bunch of other complexity in there, which I'm not going to talk a ton about, but the complexity goes away with some of the work that we're doing with the Azure automation as well. So you generate that MOF, package up your resources, put them all up on the pull server in the central repository, and then the target nodes go up to that pull server, pull the configuration down, and enact that configuration. And if the configuration needs additional resources, they will go up and get that up there. And this is the part that enables continuous deployment. So the way that we do continuous deployment is in the environment that I talked about earlier. You have environmental configuration and you have structural configuration. So the environmental configuration are things like the number of servers you want to deploy to, the site where you want the website to be installed, a bunch of things like that. That kind of stuff might change between your environments, so you can separate that out from your structural configuration. And your structural configuration is, I want to make sure that I have IIS installed. I want to make sure that N websites are there. I want to make sure that I have these files there and stuff like that. So it's that structure that's not going to change from deployment to deployment. And that way you can be sure that as you go from dev to test to production, that you're going to have the same result. But it gives you the flexibility to make some tweaks to that. And then the make it so phase is just that imperative logic that the resources themselves provide. All right, so I am, availability. So DSC first shipped in Server 2012 R2, and 8.1, that was version 4 of PowerShell. It's available through WMF as well, WMF 4 down level. That was our first release of DSC. We have started shipping all of the work that we're doing for Azure Automation and otherwise. We're shipping it in WMF 5 previews. That is available down to, I guess, Server 2008 R2 now. And that ships on a regular basis. So we're doing it like every month or every 2 months. We're getting that stuff out there for you guys to take a look at, use, and give us feedback on. We have kind of 2 classes of things that we have in there for features. We have stable stuff and we have experimental stuff. That allows you to basically make a decision whether you want to put it in a production environment or not. The stable bits are things that we make the promise to you that it's not going to change. So if you deploy that in your production environment and a new version comes out, we're not going to break backwards compatibility of that stuff. With the experimental stuff, we almost guarantee that we will break backwards compatibility. So it gives you that earlier so you can give us feedback so we can make changes. So it's very quick turnaround, if you will. The other 2 things are the resource kit. So all of the resources, we ship 12 of them in the box. There are 170 of them out there right now that Microsoft and company ships. They're on GitHub, and we have a PowerShell gallery as well. So you can download those and make use of them, change them. They're just modules. So. All right. So a super quick demo here so that we can move on to the good stuff. I just wanted to give you guys, show those of you who have not played around with DSC all that much what it looks like as DSC without Azure Automation in the picture. With DSC, you have a configuration. Configuration acts just like a function. So you define the configuration, and then you call the configuration, which I'm not doing here, but in this case, it would just be Pet Shop web app, if I can type. So that would call it, and when you call that, it generates the MOF document, and then you would use a commandlet, start DSC configuration, and point it at the directory where that was, and it will actually send that MOF to a target node. So that's kind of the push model. The pull model would be I generate that MOF document and put it up on, after I do a bunch of stuff to it, and I put it up on the pull server and pull it down. So inside of the configuration, you can have parameters and all that kind of stuff, so it behaves exactly like a function. So if you're familiar with functions in PowerShell, you're familiar with that. But the real power of the DSC configuration scripts is what the configuration looks like. It's just, like I said, it's a very declarative model where you come in and say, I have a firewall that I want to configure. These are the properties that I want it to have, and make it so. I'm not going to tell you how to do it, just make it happen. So it's very easy to read, very easy to make changes to, and things like that. So that is DSC configuration. And I'll get into this configuration here, and I'll kind of tee it up for the next demo. This configuration is a configuration that will deploy the Pet Shop web app. I don't know if any of you have played with it at all, but it's a Microsoft app that's there for learning .NET. It has the ability to be a multi-tier app, so you can deploy a front end and the back end. And what this configuration does is it deploys that sample application, and it deploys sample data to a SQL database, and then stands up a front end. So basically, I'll have 2 servers, 2 configurations. I'll stand up, well, SQL is already installed in one of the boxes, but I'll configure SQL so that it's ready for the Pet Shop web app, and then I'll stand up IIS and install the web app and all that kind of stuff on the IIS box. So all using DSC. And with that, I will hand it back to Joe.
All right. Okay, so we've kind of started on this journey from doing configuration manually checking if things are still in configuration, and changing it back to be in the right state, to using Azure Automation runbooks to basically run PowerShell scripts to check into VMs, are they compliant with my desired configuration, my IT rules? If not, going and fixing that automatically and reporting. And then resolving some of the little things you wouldn't want about that using PowerShell DSC, where it's now all declarative. You say, I want it this way, make it so. And it handles the checking if it's not in that state, the code behind the scenes to do that. It handles the setting it to be in that state, and even reporting on information. Okay? You don't have to open ports if you use pull mode, because the nodes will actually, as long as they have outbound access to the pull server, they can pull down what they should, the desired state they should apply, and they can report back up to that reporting server that could be the same or different than that pull server to say, hey, I'm in compliance, I'm not in compliance, I failed to become compliant, here's exactly where I'm compliant and where I'm not. But so PowerShell DSC is a technology. It's a tool. It's not really a solution. So our argument is there are some issues you run into when you try to use PowerShell DSC at scale today, just like when you try to use PowerShell at scale today. Kind of Azure Automation solved the manageability problems of PowerShell at scale, and now Azure Automation DSC will be solving the PowerShell DSC kind of problems of using it at scale. And just to cover some of the problems you might run into as a really big enterprise trying to use DSC to specify the desired state for your VMs, your physical host, and actually applying that, seeing the reports. There's a lot of items in PowerShell DSC. So Mark kind of went through this. On the left, you have the configuration script, really. This is in PowerShell. But you can see it's nice. You declaratively say what you want. In this case, I'm saying the web service role, every node, every VM that should get that should have IIS and ASP.NET installed. This is obviously a very simple example. When you run that to compile it, you get, in this case, one node configuration. A node configuration is the same as a config document. It's the same as a MOF. It's just a new term we're using for it. And you'll have one or more of those node configurations spit out depending on how many node statements you have in your configuration script, the thing on the far left. Not to mention, if you want to put these on a pull server, in addition to generating that configuration document MOF, that node configuration, you also need to create checksums of it and put those on your pull server, which you have to do manually right now. And then there's pushing these to nodes, nodes being a target that you want to apply your desired state onto. You want it to make sure it matches your desired state. You can push it in, or you can have it pulled down from a service. But there's a lot of items. I mean, if you have thousands of nodes and hundreds of different roles created from what could still be hundreds of different configuration scripts, that's a lot of items to manage. And some of the problems you run into around that are the big three. How do I limit access? How do I track change and compliance? And how do I orchestrate changes? So in terms of how do I limit access, it's both how do I make sure only the people who should be making changes to my configurations do so? Because different people may only have access to different parts of your configuration, right? The person responsible for security isn't the same as the person responsible for the app layer, for example. You may want to separate those configurations out, but still allow the node to get all that information, because both pieces of that end up being what the node needs, even if it isn't the same person doing it. And not just creating them, but also compiling them. Who actually gets to turn these into node configurations, config documents, and put them on the pull server? Because you may not want them to go there at a certain time, because if the node checks in and sees it there, it's going to run it. And you may want to wait until a maintenance window happens to actually go and do that, instead of just having it at some willy-nilly time go up there. And then there's also, basically everything around RBAC for DSC. And then there's also nodes. If you have a node that gets compromised, you don't want that node to be able to go down. If it's a web server, you don't want it to be able to pull down my AD cluster configuration, right? That's something you want to keep locked down to only the nodes that should really have that configuration. You don't want nodes to be able to request everything they want from the pull server. So you need to limit access there. And in terms of how do you track change and compliance, some of the issues are, how do I know who made what edits to what configurations when? How do I know when they generated node configurations from node configurations? How do I know who is changing what node is mapped to what role, a role being defined by one of those node configurations? And how do I know at the node level what's compliant and what isn't? Am I looking through a bunch of files? Am I remoting into a bunch of VMs and looking at log files? Or is there a better way where I can see it all aggregated up in one interface rather than having to go look through tons of files just to see what's compliant versus what's not? Then the orchestration piece is, making a configuration change could be part of a larger service change where you have dependencies on different roles between the service in terms of what order the configuration change should be made in. You only want to make configuration changes during a maintenance window maybe, rather than at any time during the day. Maybe you only want to have it happen at midnight when no one's using the service, so it won't affect availability. And maybe you want to do something like upgrade domains, where when you actually change the configuration, you only want to do it on a subset of every VM or physical host in that tier at a time, and only once it seems to have worked on that set, move on to the next set. Both to test that it's working correctly before you push it out to everything or have it pulled by everything, and also to maintain availability if some of those nodes might need to temporarily go down or restart to apply that new configuration. You wouldn't want to take down all of your nodes at once. So orchestrating processes is another thing that's hard with DSD at scale. So how I kind of think of it is there's this Latin term, who will guard the guards? And I think of it the same way here, because PowerShell desired state configuration makes configuration management a lot easier. It democratizes configuration management. But now you have all these PowerShell DSD items, nodes, checksum files, node configuration, config docs, configuration scripts that you're now trying to manage and limit access and see when changes happen to them and what nodes are compliant and what aren't. And so how do you now democratize that set of things? And that's where Azure Automation DSC comes in, where just like we add a management layer on top of PowerShell today to make it easy at scale, we will now be doing the same thing for PowerShell desired state configuration to make it easy at scale. What Azure Automation DSC is basically a PowerShell DSC pull/reporting service hosted in the cloud. No more setting up your own pull server. You just add an account in Azure Automation, you have a pull server now. You have a reporting server now. You can hook up Azure VMs, on-premise VMs, AWS VMs, anything you want to it, or physical hosts. And they can all pick up some desired state from there, match that desired state, or fail to match it if they can't apply it for some reason, and then report back on their compliance with that desired state back to Azure Automation DSC. PowerShell DSC supports both Windows and Linux, so you can use this for both desired state of Windows and Linux boxes. Linux we don't quite have working with Azure Automation DSC yet, but we know everything we have to do. It's just a matter of getting it done in the next few weeks. Part of the Azure Automation service, so if you have an automation account already, you now have a pull server in there. You just need to onboard to the preview of this by running one commandlet. And basically what it gives you is around those configurations, those node configurations, those nodes and those DSC resources, the same kind of management you get for runbooks and assets and jobs today. So ability to import them, author them in our system, compile configurations into those node configurations, have versioning, make it easy for nodes to become onboarded to our pull service, our reporting service, so it's easy for them to grab things, apply them, and report back on how they did. And all the management tasks you need to do around PowerShell DSC, from authoring to compiling to hosting it on the pull server to viewing reporting information afterwards to onboarding nodes. So traditionally how a DSC pull server looks is, and Mark kind of talked to this, on some device you write a configuration script, you compile it, you now have those node configurations, config documents, you generate checksums from those, you zip up your resources, you put all those on a pull server that you have to manage yourself and stand up yourself, and one or more VMs, as long as they have outbound access and can reach it, will go and pull from there and report back up to there. But of course today what they're reporting is basically log files. There's no better interface to that information besides looking at log files. Azure Automation DSC, the same kind of things happen, but the work you end up having to do is a lot less. The configuration scripts you put up there, you compile them into those node configurations, config documents. We generate the checksum for you. We host it up there on the pull service. You don't have to set up your own pull service or maintain it. Same with the reporting endpoint or the resource endpoint where the resources are hosted. Just like you can import PowerShell modules into Azure Automation today, you can now import PowerShell modules that contain DSC resources, and they'll show up on the DSC pull server so that if nodes need those resources, they can be pulled down And to the nodes, there's no difference whether they're talking to a file share pull server or Azure Automation DSC. They just, as long as they have outbound access to it, they can reach in, grab things from it, and report back on their compliance. In terms of how the resource tree looks, we have everything, all the different kind of resources in Azure Automation in here. The ones in bold are the new ones. So within modules, we now discover DSC resources and expose those to be downloaded over pull mode by VMs and physical hosts hooked up to using the DSC agent. We have configurations that are kind of just like runbooks in there. You write them in our system or import them. You run them, whereas when you run a runbook, it actually goes and does some tasks. When you run a configuration, really we call it compiling the configuration, all it's doing is producing those config documents, MOFs, node configuration, all those are the same term, and putting those on the pull server. And then nodes are actually hooked up to one of those node configurations to say, maybe this node is a web server, so it's hooked up to the SharePoint.web server configuration and has to match that state. Or maybe it's just a general configuration that defines all of your nodes should be hooked up to operational insights, right? And the configuration defines you need op insights agent installed. Here's where to get it, so make sure you have that file, have it installed, and then not only will the desired state of the configuration be reported to us, but now you have op insights installed, so you can ensure that all of your infrastructure is now reporting, monitoring information up into op insights. That's just one example. So it's limited preview right now. There's no UI, it's purely commandlet based. It's not meant for production yet. We basically want to give it to you early to start playing around with, get your feedback on it, what's working, what isn't, what's missing. And then over time we'll be adding more and more to it to get it up to that production ready state. There's no pricing on it yet. We'll determine that later in the year. So it's just an early preview for you to start playing around with. And in terms of how you onboard to it, this is in the documentation on it, which is online. But it's basically you run these two commandlets, and that's how you essentially sign up for the preview. And then you get access to all the rest of the commandlets, which ship in the Azure PowerShell module for doing things like importing configurations, starting those compilation jobs to create node configurations, seeing what nodes are hooked up to what node configurations, seeing what state of compliance different nodes are in, viewing the raw reports that nodes are sending up to the server. And we make onboarding very easy as well through commandlets and through some other ways, which we'll talk about later. So now I'm going to turn it over to Mark to show a demo of Azure Automation DSC.
All right. So now what you've all been waiting for. So I described kind of what I'm going to be deploying. I'm going to be deploying it in Azure, so against a couple of Azure VMs, just because it was easier for me. I don't have a ton of RAM on this system, so I couldn't have multiple machines up and stuff like that. I will actually show you how I can pull it down to a VM on this machine as well. But basically, I'll stand up IIS on one machine, SQL on the other machine, have them connected, and have the Pet Shop web app come up. So to do that, I will start by just basically running these commands, and what they do is get my automation account. So we switch to the resource manager mode, which basically says use ARM to use these commandlets. And then I'll log in as myself, and unfortunately, actually, I think I'm already connected. Yes, I already am connected. Good. So that will get the automation account for me. So I have my automation account now connected. I already created an account, so I'm working against the account that I already had, so we don't have to wait for some of that stuff. So I'm in my automation account. This is just an account, like if you have an automation account, you can work against that one now. As soon as you run those commandlets that Joe talked about earlier, you'll have the access to use the pull server and stuff like that. So you work against existing automation accounts if you want, or create new ones. And then I'll go ahead and get some information. So one of the things we have not talked about yet is to onboard a machine to Azure Automation. We want to do it in a secure way. So in order to do that, you give an address for where the Azure Automation endpoint is, but you also give it a secret, and that secret's used to onboard the machine, and then that secret's removed from the system from then on, so the machine is registered with the endpoint, and then it can communicate by itself after that. So someone else can't go to that machine, pick up that secret, and then onboard another machine. So it is a secure way. So to do that, I need to get that information from Azure Automation. and I will do that here. So I'll talk to my account and get the primary key, and then I'll get the endpoint. And what I'm going to do, I have two Azure VMs already stood up, but I'll show you the process of actually onboarding one with another VM here. So I will first copy the URL. And if I come in here, I'll go add, and I'll add a new VM. And I'm just going to pick the smaller of the two, so I'll pick a plain vanilla Windows Server 2012 system. I will wait for it to figure out my resource groups. For 1 second. How many of you are using the new UI in Azure? Okay, a good number of you. So you're familiar with this UI. Give it a second here. All right. So I'm going to give this just a ignite temp name. And I'll put my name in here and my password. All right, and then size D1 is fine. It doesn't like my password 1, so I'll come up with another one. Have the password, pick the size, and then let me move this to a different resource group too. I'll come in here, and the magic behind this is the extension. So I'm going to come in and select an extension, and the Azure Automation team has added their own extension, so it really streamlines the process of onboarding Azure VMs. So you come in here and use that extension. That happens to be built on top of the DSC extension, so it uses DSC to configure DSC, which is kind of cool if you ask me. But I'll come in here and paste in that URL. If any of you have used Operational Insights, you're very familiar with this whole process. And I will use some of the shortcut keys that I learned at the keynote to switch desktops, which is awesome. Copy the secret and go back and put the secret in there. And as you can see here, you can basically tell the node that I'm going to onboard you, and I want you to be this specific role when I onboard you. After that point, the server is authoritative, so the server says, this is what you get, but we give you the ability in Azure to basically say, when I first come up, I don't want to have to go twiddle with anything on the server. I just want it to come up as this thing. So I will actually be showing you how to actually, on the back end, say, I have these servers in my resource pool, essentially, and I'm going to assign them these addresses, but this gives you the ability to actually bring a system up, point it at a configuration, and have it just come on board right away. I won't do that here, but you say OK, and OK, and OK, a few more times, and I'm not going to pin that. And then you create that, and that'll bring the machine up. So that'll bring it up, point it at Azure Automation, and then you can do the management from Azure Automation from there. So I will jump back here to my configuration, and basically from that point, once you point your machine at Azure Automation, you don't have to touch it again. It's at Azure Automation. You can manage it from the central point from then on. You can give it an initial config. You can change that config. You can do all that kind of stuff from the server, which is extremely powerful. So what I'm going to do here is the next step, I would import all of the resources that I'm going to use. So my configuration has a bunch of custom resources. So I would import them in here. That takes a few minutes because they're packages and they have to be copied from a link. So I'm going to skip that. I've already actually done that. But the next thing I'm going to do is I'm going to import my configuration. And what that's going to do is basically take the configuration that I have over here and import it into Azure Automation. It's going to import it as a PS1. And then my next step will be to actually compile that thing. So I actually don't have to copy the comment. All right, so that is going to import that thing and get the configuration back so I can use it later on in my script. And then I will go ahead and compile that thing. So I will run my compilation. And this is going to take a couple of minutes. I'll just do this one. Because what this does, if you're familiar with Azure Automation, it's going to spin up a sandbox environment. It's going to inject everything you need into it. It's going to run that configuration, generate the auth, pull that MOF out of there and put all of that stuff up on the pull server after it does all the checksum and all that kind of stuff. So in that one step of doing the compilation, it's going to do all of that stuff, magic stuff for you. So with that, I will kind of show you what I have for systems up in my environment right now. So if I do the get Azure DSC node, it gives you information about the nodes that are registered with Azure Automation. And you can see here I have two servers that are registered, a demo SQL server and a demo SQL IIS server. So the next step I'm going to do is basically tell the systems what configuration to get and to do, well, actually, let me look at what configurations I have first. Here, I'll look at what configurations I have available on the Azure Automation site.
Which MOFs are there, right?
Yes, node configurations, yeah, that's right. So this shows me all of the node configurations I have up there. So I have the, what this does is if you have used DSC, when you run a configuration, the node statement, basically for each node statement you have, it generates a single MOF. So if I come over here, when I run this configuration, I get a single MOF for each of these things. In the initial releases of DSC, the way that we had you use it was to create a single MOF for every single server, which customers, one, told us they didn't like, and two, they didn't do that anyway. We tried to kind of enforce that with GUIDs and stuff like that. And what you guys did was, all right, you give me a GUID, I'm going to apply that GUID to all these machines, so all these machines are just using a role anyway. So we took that feedback, in addition to the requirements from the Azure Automation guys, and have let you basically have a role of servers. So I'm going to have N servers that are SQL, N that are IIS, generate the MOF, put those two MOFs up on the pull server, and then point all of my machines at those individual MOFs. So what we do is when Azure Automation runs, it generates a namespace, if you will. So it takes the name of the configuration and dots that against the name of the MOF that's getting generated. So you have a unique, for each application, if you have a SQL configuration, you can have the application name .SQL, and it makes it easier to find and makes them unique and stuff like that. So that's what these are here. So those are the node configurations. So what I'll do is take the information up here. So we also have a unique ID for each of the machines. So because machines can potentially have the same name and stuff like that, when DSC boots up for the first time, it generates a unique ID that it uses to communicate with the server or to identify itself with the server. So that is what you're going to use to link up your configuration to the unique node. So that's why I wanted to run this. And you can see here that these two nodes don't have any configurations assigned to them here. The node configuration is blank, so that means I'm registered with the system, but every time the agent asks, it's going to say you've got nothing. So what I'm going to do next is actually tell it what it needs to do. So that is this statement here. So I'll grab that and actually inject my, hate that. Copy that again. And inject that after put the ID in there. So I have these IDs up here, and that is for my SQL server. So I'm going to grab the ID of my SQL server. And again, this whole process, when the UI is done, is going to be much more streamlined. You won't have to worry about these agent IDs and stuff like that. You'll see your machines, you'll link them, and it'll all be much easier. So I will link that here. So yes, I'm sure I want to give it that, and then do the next one. All right. All right, so now I have my node configurations. I have my servers connected to my nodes, or to my configurations. So if I run that command again here to get all of my nodes, my node configurations, where is that? This guy. So if I run these commands again, you'll see that the nodes actually have configurations assigned to them. So in here, you'll see the pet shop web app is actually assigned to that node. So now I'll go out to my node itself. So if I switch back to this system over here, I have the two nodes up and running. So this is the IIS server. And you can see over here that if I do a get Windows feature, that if I actually did the star thing, you would see that IIS is not installed on here. And there are no websites, obviously, because IIS is not installed. So give it a second here to finish that. And if I scroll up here, you'll see that IIS, did I go by it already? No. IIS is not installed and none of the stuff is there. So now I will do, this is a new command for those of you that use DSC, the update DSC configuration. And what that does is say, go up to the pull server where I've told you to be and get your configuration. So I'm going to run that guy, and it's going to go up and get the configuration that I assigned to it in Azure Automation, pull it down, and enact it.
So normally, the DSC agent would do this on a regular schedule. But just for demo purposes, we're making it kick off right now so that there's no waiting involved.
Yeah. Thank you for that clarification. All right, and I'll do the same thing over here on the SQL Server. And like I mentioned, the SQL Server has SQL installed. This script is going to do some configuration so that it works over there. So I'll just do the update DSC config here. All right, so that's going to run those two configurations and get them all configured up. So while that's happening, I will come back here and show you kind of the status. So you can see by running the get DSC node, we tell you what the state is of the different nodes. So this will go through and say, all of the nodes that are registered with my environment, this is the state that they're in, and then a bunch of the other information. So you can see here that I have the Ignite IIS and the Ignite SQL. They are currently compliant because when it first registered, there was no configuration assigned to it. So it's in the process of actually doing that update now, and it'll report back. The way that DSC works is if it hits any errors during the configuration, it reports back right away. But otherwise, it just waits till it's done doing the configuration, then it reports back then. So let me check the configuration status here real quick on the other machines. And if those are not done, I will. So those are in the process still. The IIS one takes a while because it's installing IIS. The SQL one should be a bit quicker. So that is all done. It ran and successfully applied. So if I went into, I think we have a minute. If I go into SQL and connect in there, you can see in the databases that we now have some pet shop databases created, and there's some sample data in there.
And if you ran it again, what would happen?
If I ran update config again, what happens there is it goes up to the server and says, do you have a new configuration for me or a different configuration? And it'll say, nope, you've got the one that you should have, nothing left to do. If you want to actually reapply the configuration that you have on the system, we have added start DSC configuration -use existing, and that says, I have a configuration on this box that I want to reapply. Go reapply that right now. I don't want to push a new configuration to the machine. I just want you to apply what you have. And you can do that locally or remotely or what have you.
Yeah, and again, this is something you could do to kick it off manually, but the DSC agent is going to continually run both to check the server for something new to apply and both to, for the last thing it was told to apply, make sure it continues applying that to stay in the desired state, if you told it, it should stay in that desired state, as opposed to just report when it leaves the desired state.
All right, so while we're waiting for IIS to come up and praying that the demo is going to work, it's been good so far, lots of yellow, no red, so I'm happy with that. What I'm going to do is show you how to actually onboard a system that's not in Azure. So we have a commandlet, or Azure has a commandlet that they wrote that allows you to pull down the meta config. The meta config is the configuration that configures DSC on the target node. So basically it has the location, the HTTP address for the endpoint, it has the registration key and all that stuff already in the meta config, so you can just take that, put it on the target node that you want to connect to Azure Automation, and tell it to run that, and it'll go connect and do that. So I will grab that and run that guy. So it's going to create that MOF document. So if I go to that directory, grab that MOF document, I can take that and go over to my local machine over here and paste it in a folder. Not folder, let's create one. Configs. So I have a configs folder, I paste that document in there, and then I can go set DSC configure or local configuration manager and point it at that directory. And do a wait, or no, there's no wait, dash verbose. And that will basically set the meta configuration, so this system is going to go up to Azure and pull the configuration down. And before I do that, I have to link this system up to the configuration that I want it to go get and pull down. So I'll go back to my script here real quick. And I will get the server. No, I already did that. So get the node configuration so that I can see that server over here. So this is SQL VM, and you'll notice in here that I have two VMs, or two systems registered. This was a system that I had before that's in there. They have different unique identifiers, so that is how you can actually have, if you have a system that you spin up and spin down, or that you blow away and then create another one with the same name, it'll show up in the system as a different item because it has a different unique ID. So that's what that shows there. So I'll take that ID and actually put that in here and run that guy to link it up to, oops, oh no, that's reporting, sorry, wrong one. All right, put it here. I think I'm going to have to go back, so this is all right, so real quick here, copy, paste. Oh.
I think you have a comment at the end and an extra quote.
Thank you. All right, try that again. All right, so I don't know. I'm going to give up on that one.
Still an extra quote. It's in front of $my automation account, I think.
What's that? Oh, well, I'm going to give up on it. Trust me, I can point this at the server, and if we wait long enough, it's going to go up and get it anyway. So I would go up and get the configuration, pull it down, and apply it. So let's just check real quickly to see if IIS actually is done doing its configuration and if it actually worked properly. It is not. So we're going to jump back to the slides, talk, and then come back to this and see that it's done. But basically that showed you the flow using the commandlets of basically plugging systems into Azure Automation to get their configurations.
Thanks, Mark. that's a great example of how you can, even if we don't have a UI yet, use the commandlets to bring in configurations, compile them in our system as jobs, just like runbooks have jobs. Once the things have been compiled, you have those node configuration MOFs placed on the pull server, checksum generated for you, and very easily through a number of different ways. I think we actually have 4 different ways to onboard nodes, whether they're in Azure or on-premise. Mark actually showed one of the Azure and one of the on-premise ways to do it. So it's very easy to just hook those things up to the server, change on the server side what role, what node configuration MOF they're mapped to. If suddenly a web server needs to become a worker, or web server v1 needs to become web server v2 as its role. And actually go and just configure your whole environment and keep it in the desired state you want, and actually be able to view reports to see that it's actually in the desired state you want, or if it's not, what actual errors came up. So now Azure Automation is a system that cannot just run imperative code, processes via runbooks, but it can also host your DSC configurations. So now a question we get a lot, even before DSC was hosted in Azure Automation, was, well, when do I use runbooks versus when do I use PowerShell DSC? And really how we think about the interaction between that is PowerShell DSC is great for declaratively saying how I want my infrastructure to be configured. No opening ports, no writing, imperative script to say what you want. It's just declare this is what I want rather than how to get it that way. Whereas runbooks are for, since they're scripts, they're for orchestrating processes. So that could be, things that you can't really model declaratively, like when my SQL server approaches maximum load of what kind of data it can store, go and clean up, the oldest n logs from the logs table of that SQL server. That's not something you can really model declaratively with DSC or even with, ARM templates or any declarative format. So processes with runbooks, the configuration for your VMs or physical hosts with DSC. And then the interaction between the two may be a process that actually involves DSC. So you would have a runbook wrapper that can actually call into the Azure Automation DSC side of things. Since, as you saw, we have a whole bunch of commandlets, and commandlets can be used in runbooks. You could actually, from a runbook, talk to the DSC side of things. So say I had a process that involved DSC, such as I have a runbook monitoring my source control system. When I actually commit a new version of my desired state for my systems, my desired state configuration, the runbook can pick that up, automatically import it into the Azure Automation DSC side of the service, compile it to create the node configurations, make sure that the staging environment nodes in infrastructure VMs are hooked up to it, and run the test suite to make sure that they're actually still serving the application, everything's still working correctly. If the tests fail, email whoever committed that to say, hey, your configuration broke the system. If the tests pass at the correct maintenance window time, actually deploy the update, upgrade domain by upgrade domain to a set of nodes hooked up to Azure Automation DSC, those being the kind of production VMs now instead of the staging VMs. So a process around configuration is where you would use runbooks to orchestrate the Azure Automation DSC configuration side of things. So we don't have UI yet, but we do have a lot of mock-ups about what this thing would look like. So I'm going to switch over now to my laptop and show you some of those mock-ups. When are we over at 4:30?
Yeah, 6 minutes.
6 minutes, all right. That's you. I'm 8.
The script did finish finally, by the way.
The script finished. So we now have PetShop deployed, which is really great because it's a SQL, it's an application with IIS and SQL Server that you could configure across clouds. You could have the SQL on-premise if that's where you wanted to keep your data, and have the web servers up in the cloud on Azure, and use DSC in one Azure Automation account to configure both, regardless of the fact that one's in Azure, one's on-premise. You could have parts in AWS, wherever you want. So this is, these are actually mock-ups. They look pretty real, don't they? So this is what our Azure Automation kind of dashboard would look like with configurations in here. So there's 3 kind of different actions you would take in here. Creating configurations, compiling them into node configurations, onboarding nodes, and viewing reports about things. Mark already showed some of the onboarding node stuff, so I'm going to skip that in the interest of time. So when I click into configurations, just like I would get a list of runbooks in here today, I now get a list of configurations. Configurations act a lot like runbooks in terms of what kind of information they expose, what I can do on them. So if I click into a configuration, just like a runbook, I can edit it up in here. With a runbook, I have the start command, and here I have the compile command. Just like start creates runbook jobs, compile creates configuration jobs, which I also have tracking on in here. I can see when they started, who started them, what node configuration MOFs were created from each one. I can also just see a general overview of, you have this configuration, these node configuration MOFs were created from it, and these many nodes are hooked up to each one. All of these things are clickable so that you can get more information on anything. If I click into a job, I can schedule configuration compilation as well. If I click into a job, just like a runbook job, I get information on who started it, when did it start, what input did it take, what node configurations did it produce. I can see the source at the time that the configuration was compiled, if this is something in the past. I can see any errors, verbose logs that came out of trying to compile this configuration into a node configuration MOF. I can see that in the past over time as well. I can see a list of my node configurations, of course, and any schedules I've tied compilation of the configuration to. So that's kind of the life cycle around importing configurations, generating them, creating node configurations. Now, if we go into the reporting side, you can see we expose both aggregate level and very granular level reporting in here. All this data is already stored in our backend. It's just a matter of building the UI to expose it to you via more than just commandlets. We figured since you're already writing PowerShell DSC, having a commandlet-based interface wouldn't be so bad for an early preview. So you can see in here we have a list of all the node configurations in the system, basically all the roles in the system that my nodes are supposed to conform to. So if I click in and I can see what state they're in, failed, not compliant, in the process of applying something new, which is pending. If I click into any of those, I can go from, again, I have a little bit aggregate reporting on, here are the nodes for that node configuration, the nodes picking up that node configuration MOF. I can click into any of those nodes to not just see its status, but also see for all of the different resources in there, what state are they in? Are they compliant? Are they not compliant? Did that specific one fail? What error message did it have? And I can see all that in the past. So I can go back over time and see how things change in terms of when did this node go non-compliant at some point and then become compliant again? Has it continually been in a failed state? So I probably need to go and fix something on there. And I can drill into both in the past and for the current version. Again, you see we have a nice resource map of this node's hooked up to this node configuration. Here are the resources it's supposed to have and what state they're each in. I can click into any of these and get very detailed information about not just the node configuration, not just the node, not just a specific report, but a specific resource even. So if I click into a specific resource, such as Windows feature, also notice we'll have composite configurations exposed in here. If there's any errors on the report, I can see that. If I click into a resource that failed, so within a resource, I have a bunch of resource instances, right? Because I may have more than one Windows feature resource. If I click into that, I can see all of the different properties that resource had, what state it's in, how long it took to run, what specific error it had. So you're getting both very high-level aggregate information about what's the state of my system overall, what are the state of my roles overall, and also if I have issues, be able to drill for current time and in the past into exactly what went wrong or what the very granular state of every node in the system is, every resource in the system. So I think with that, we'll go back to the deck in our last minute.
All right. So I just wanted to, we get the question very often. I have System Center, Configuration Manager. How does DSC kind of compare to that? And that is, since I only have 48 seconds, it's an unfair question, first of all, because System Center is a solution and DSC is a platform. So it's not really an apples-to-apples comparison. It's more of a, I have System Center, should I use Azure Automation? And we've been working very closely with that team and coming up with kind of some guidance for you guys on when to use System Center Configuration Manager, when to use Azure Automation, or things that are built on top of DSC. And this is kind of what we've come up with. The DCM is very good at configuring clients, first of all, configuring something and letting it stay that way. So I configured it. It's that way. It's going to be that way for a long period of time. Where DSC is kind of I'm going to make changes to things on a regular basis. I'm a web app developer, and I am going to make changes. I'm going to deploy my web app on a regular basis, and when I do that, I need to tweak little things in SharePoint when I do that. So DSC is very good at that because you can check stuff into a build system and have that whole process automated and stuff like that. So that's kind of the very quick overview on kind of when System Center and when kind of Azure automation type stuff.
And this is not just our side of it. We've talked to the config manager side of it, and they have the exact same slide in their presentation about config manager for servers.
And this is the other piece of that is we want your feedback. So come talk to us either after this or ping us or whatever. Just give us feedback on how you feel about it and stuff like that. So, and they are continuing, or we together are continuing to investigate what it looks like going forward with DSC. So, all right, with that.
I think with that, we're going to open it. There's a summary, but I think you guys get it. There's a lot of different resources we have in this deck if you want to go and get more information. There's a whole bunch more Ignite sessions and forums where you can ask us questions and see more details about anything we talked about. Azure Automation, non-DSC side, DSC resources specifically. So with that, I know we're a tiny bit over time. We're going to stay up here and answer questions if you guys have any. Thank you for joining us today.
Yep, thank you guys very much.